Hi everyone, welcome back. Today we are going to see about the distance protection of transmission lines. So the distance protection of transmission lines which are used to protect the high voltage transmission line, extra high voltage line transmission line, ultra high voltage line transmission line. So it is mainly for HV, UHV, like etc. So this is to mainly to protect the transmission lines from the fault or some of the disturbance in and around the line. So the distance protection is also known as line protection, or it may be called as distance protection. So which is very crucial to safeguard this infrastructure, that is from the potential damage. This technical methodology which are employed for the distance protection of transmission line, which is more important to ensure the reliability and efficient transmission of electricity across various distances. And these are the various faults which are occurred in the transmission line. One is short circuit fault. So this is mainly in any one of the line or two of the line all the three lines are cutted and it is connected with the ground. So it creates a short circuit. And second one is open circuit. Any one line or two line or all the three lines which are cutted but it is not connected with the ground. So this is called open circuit fault. And another one is ground fault. So these are the different types of fault which are occur in the transmission lines. And the principles behind the distance protection, it is based on the impedance value. It is based on the impedance value and based on the directional sensitivity and based on the coordination with other protection. So these are the principles. So the first one based on the impedance protection. So here we are from the sending end, we are sending some of the current and it flows through the line till where the fault is occurred. And till that particular current is traveling till the fault current and the fault location, and again the current will be returned back to the source. So we are measuring the sending current as well as the receiving current. So how much current gets dropped. So based on the dropping, we can able to measure the impedance. Based on the impedance where the fault is occurred, we can able to easily measure. And directional sensitivity. So the direction is nothing but the direction of current. It is based on the direction of current, whether the fault is occurred within the zone or between the zone or outside the zone. So we can able to send. And the next, it is connected with some other protections. So such as overcurrent relay, differential relay, etc. And the distance protection technique. So here we are using distance relay, pilot relay and microprocessor based relay. So we can use any one of the technique to determine the distance protection of transmission lines. And the challenges and advancement. So one is increasing line length. So a transmission network expand to the accommodate growing energy demand. So we can able to the challenges which are faced in the distance protection. The impedance based detection method may become less accurate over longer distance. If you go for long distance, the impedance maybe gets delayed. And environmental factor. So it is because of humidity or some other electromagnetic influence due to the telephonic lines. And based on the environmental condition like the extreme level of temperature and the cold, so it may give some of the challenges to the transmission line. And integration with the smart grid. So here the data analytics and some of the integration method which are adaptability to power system and cyber security concerns. And distance protection system become more interconnected. A risk of cyber threat such as hacking and data manipulation must be addressed through robust security measures and protocols. And reliability and redundancy. So here the distance protection often feature and backup protection schemes such as dual winding transformers and parallel transmission line to ensure a single point of failure does not compromise the overall system reliability, and fail-safe design. So here we can ensure the relay failure or loss of power. The system will automatically trigger a safe shutdown to prevent the further damage to the transmission network. And the regular testing and maintenance has to be followed in order to for the calibration, simulation testing, and record of data to maintain the stable operation. And the future trend in the power distance protection. So we can increase the automation process, communication will be increased, and simulation based testing can be applicable, and predictive diagnostic through the system. And this is an assessment. A transmission line distance protection relay having the property of being inherently directional is one is impedance relay, mode relay, home relay, reactance relay. So put your answer in the comment section. And these are the few reference books for this topic. Thank you.